This is the audio amplifier. The first circuit creates a sine wave using the LM741 op-amp, and this potentiometer adjusts the frequency. The output is represented by this buzzer, creating a high-pitched sound. The next circuit takes in any audio input through these headphone wires and amplifies it using the LM386 audio amplifier, which consists of an op-amp. This potentiometer increases the volume, while this one adjusts the gain. Since the final product doesn't work, I'll refer to the breadboard prototype to explain the project. The first part of this project aims to emulate audio signals, which are best represented by sine waves. This is done through an RC phase shift oscillator, which is what is present right here. So when power supplied, the buzzer makes a loud noise, reflecting the behavior of the sine wave, which is continually oscillating. So I'll give it power and adjust its frequency. Here's how it works. The RC phase shift oscillator has a feedback network and an amplifier with gain. The input is shifted 180 degrees through the feedback circuit, which produces an out-of-phase signal and is then rotated another 180 degrees in the amplifier. This results in a total of a 360 degree or 0 degree shift, producing a necessary positive feedback, resulting in a sine wave. The op-amp has positive feedback since the output is wired to the input. There are 3 resistance-capacitance networks, and since the values are equal, each RC network contributes to 60 degrees of the phase shift, adding up to a total of 180 degrees. This shifts the points clockwise as depicted in this graphic. The resulting waveform looks like this, where the input is a reflection of the output, which is due to the op-amp inverting its input. Here is the circuit in fault state. The potentiometer here, along with the resistor, are considered as the feedback resistance, which must be 29 times the other resistor values to obtain a pure sine wave, which is called the attenuation factor. This is the sine wave on the oscilloscope. In this case, the circuit produces a sine waveform with a 6.7 kHz frequency. Here's the next part of the project, which can input an audio signal and amplify it, expanding on the previous circuit. The speaker will play Never Gonna Give You Up. This is the schematic of the amplifier. Since the headphone wire has 2 signals, one goes to ground and the other to the non-inverting input. The other headphone lead is connected to a potentiometer acting as a voltage divider. The more the potentiometer is turned, the louder the signal will be, as there is more voltage provided to the circuit. A pair of decoupling capacitors are wired to the voltage source, acting as high and low pass filters. The 10 microfarad capacitor filters high frequencies, while the 100 nanofarad capacitor filters lower frequencies. This prevents unwanted noise from being amplified. Additionally, the 100 nanofarad capacitor and the 470 nanofarad capacitor here act as additional decoupling capacitors, filtering low frequencies. Pin 7 has a 10 microfarad capacitor to prevent abrupt changes in voltage from affecting the output. Pins 1 and 8 are the amplifier pins, which can control the gain of the audio signal from 20 to 200. Finally, the speaker is wired to pin 5 with a 1 megafarad capacitor to prevent the speaker from overheating.